going to do today is talk to you about cakes to computers, the story of Joseph Lyons and Company's development of Leo, the Leo 1. I'm going a bit broader than that because I'll start by giving a bit of an introduction about, first of all, computer development, especially in the UK, between the 19th century and the present day. And also the development of the Lyons Company, which then led to, in the 1940s, Lyons being a major contributor to development of commercial computing. You've been given a background, but I'll just highlight a couple of other things about my own knowledge and development. I never worked for Leo. But I did work for ICL from 1967 to 1984, I think. And in 1968, we merged with English Electric, Leo Marconi. And a lot of people who came into ICL in 1968 from that merger became either my colleagues, my bosses, or my subordinates. So I learned an awful lot about the Leo company and Lyons, and a lot to admire, which is why subsequently I've gone back to, so it's become part of the Leo structure, if you like. The original material in this thing was composed by Neville Lyons, who was I think a nephew of Joseph Lyons, and Alan Cooper, who was a Leo Computer Society man and a Leo employee, who did a lot of work on general development of computing equipment. They comprise most of the original material, but some of it's my material as well, so it's a combination. So to start off, to talk about computer pioneers in the UK, as many of you probably know, Charles Babbage in 1822 designed something called the difference engine, and then in 1837 the analytical engine. He never actually got either of them to work. The difference engine was something that would compute tables for marine movement. Analytical engine was a general purpose computer that could do any calculations at all, driven by punch cards. He never got them to work, mainly because he needed more funding and his target kept changing. And the engineering at the time for these mechanical computers was not sufficiently good to actually make them and to make them work. Ada Lovelace was his programmer. She was the daughter of Lord Byron. And she actually invented programming, basically, and subroutines and all sorts of other stuff, and wrote programs for the analytical engine, which she could never execute, but which were programs that would have executed. The difference engine has been implemented by the Science Museum in recent years and works. And probably the analytical engine would have worked as well, but he never got it to work. But in terms of concepts, Babbage and Ada Lovelace were certainly major contributors to early thoughts about computers. And in 1936, Alan Turing, in his PhD, described a theoretical computer which had a memory which could execute programs, the Turing machine, which fundamentally underlies all of modern computer development in terms of a concept. So there were early pioneers in computers way before World War II and up to World War II in Britain, creating concepts. Because many people think computers were invented in the USA, but that is entirely not true. The USA has done lots in development, but not necessarily creative. So Alan Turing, to mention again, his work in 1936, and Tommy Flowers. In World War II, Tommy Flowers is the guy that was responsible at Bletchley Park to develop the Colossus. Bletchley Park had a problem to decrypt the Lorentz SZ42 encryption for telegraph data that the German army was using. And a guy called Max Newman developed a machine to actually do that, but it was too slow and too unreliable. Flowers, who was a lowly sort of person, was brought in, but he was a wonderful electronics engineer to actually re-engineer the machine that Newman had developed to decrypt the Lorentz SZ42, which Flowers did successfully. And if you go to TNMOC, I can give you a good rundown on how he did that and why he did that. But he was a major contributor to technology in post-World War II eras. So it was a binary machine, that's the important thing, and it was programmable. It had 2,500 valves. Bletchley Park originally declined to accept the proposal because it was going to cost them £500,000 in modern money, and they didn't think 2,500 valves would perform reliably, because their experience was their machines at home with 10 valves in had to have one replaced every 3 months. They were wrong. The reason their machines weren't working reliably is they kept turning them on and off. Flowers knew that if you left valve machines running, they would run reliably for years. So that was the situation we come to by the end of World War II. Developments of concepts like Babbage's and machines like Flowers at Bletchley Park. But now I'm going to talk a little bit about the history of the Lyons Company, and then bring that up to date about how they confluenced with each other, how they came together in the 1940s. The Lyons Company in the 1800s were a company that made tobacco and sold tobacco. And Barnett Salmon and Isidore Gluckstein and Montague Gluckstein were the partners in it. And they were basically thinking that the state of affairs in catering in Britain was pretty dire. You couldn't, unless you were a very rich person, to go to a posh restaurant, you couldn't get a decent meal for a decent price anywhere in the country. So they decided that they would actually set up a catering company that would be able to do this. And they brought in their cousin, Joseph Lyons, and formed a company called J. Lyons and Company. I think most likely, although it might not be a PC thing to say, but they thought the names of Salmon and Gluckstein were not actually good names to have for a British company because they were too Jewish. But Lyons sounded British enough. So Joseph Lyons, as a businessman, was brought in to head the company up, and he agreed to do it. And they got into the business originally by doing mass catering. They set themselves up in 1887 to do the Newcastle Jubilee exhibition. And this is in Queen Victoria's Jubilee. And then they got a contract to do the Grand Hall Olympia with its sort of Venetian. Olympia was built, and it had a whole set of canals with gondolas and things going around it, and they did all the catering. And then they got contracts for things like the Buckingham Palace garden party, Chelsea Power Show, Wimbledon, etc. And they became a mass caterer. And after that, they followed on by setting up individual tea shops. 213 Piccadilly was one that was one of the early ones, started in 1894, went still there in 1976. They went upmarket with the Trocadero in 1896, which stayed there till 1965. This was a posh restaurant. It's still there, but it's not a restaurant any longer. It's a sort of fun palace type place with lots of shops. And then they went to the Lyons corner houses, which were proper restaurants in the 1900s. Coventry Street, 1909 to 70, the Strand, 1915 to 77, Oxford Street, 1928 to 67, Marble Arch, 1933 to 77. One of the features of the restaurants and the tea shops, for that matter, were the nippies, the waitresses. They employed all female waitresses. Most restaurants in those days had male waiters. Lyons employed all females, and they were in a standard uniform. They're called nippies because they were very quick at delivering the food. And they built enormous headquarters at Cadby Hall in Hammersmith. There's a picture of it. Elm House, I'll come back to in a minute, was the management information centre. They had a pie factory, there was a college, a cake bakery, a Swiss roll bakery, bread bakery, boiler house, bakeries, medical department, cafeteria, admin block, Addison Mansions, Lyons supermarket, bakeries and kitchens, ice cream factory, and laboratories. Enormous place in Hammersmith. One of the employees there in the latter war years was Margaret Thatcher before she was married, with her chemistry degree from Oxford. I think she was responsible for formulation of ice cream or something like that. They were big investors in systems research, running this business, which post-war had about 30,000 employees and sold an enormous amount of food, required a lot of management. And they employed a guy called John Simmons, who joined Lyons in 1923, to set up a systems research department to find better ways of doing things. John Simmons was a graduate of Cambridge University, and you'll find the Cambridge University featuring quite frequently in this dissertation about Lyons. In the 1930s, John Simmons set up a whole new block of offices in Elm House as part of the big conglomerate to house management accountants, clerical staff, etc., to do basically accounting for them to understand their business better and how to make it more effective. By the time we get to the Second World War and after the Second World War, Lyons, before the Second World War, were a very efficient company running a very efficient business. But there was a bit of a shock after World War II because all the prices of clerical staff had gone up substantially and there was a huge shortage. And they got to thinking about how could we employ machines to help us run the business. And in 1947, Simmons sent a fact-finding tour to the USA of a guy they'd recruited called T.R. Thompson, another one, Oliver Standingford, again from Cambridge University, had sent them to the USA in 1946, I think it was, to study computer development in the USA. So they went to Harvard University and learned about the Harvard Mark I, which was a relay-based machine. They went to the Moore School, who developed the ENIAC, which is a machine for actually calculating the trajectories of shells, which turned out to be a bit of a dead end because it was programmed with wires and switches. It wasn't easily reprogrammed. They went to NCR and IBM to see what they were doing, and Burroughs. They went to Prudential, who were negotiating with UNIVAC about building a computer for commercial use. And they went to Princeton University, where they met Professor Herman Goldstein. And Herman Goldstein said to them, well, I don't know what you're doing here, because actually what you're after, which is a programmable electronic computer, is being developed in Cambridge University in the UK by a man called Maurice Wilkes and his boss there. So you'd be better off going back there and talking to them. And here are the two gentlemen, Professor Douglas Hartree and Dr. Maurice Wilkes. Wilkes had been to the US in 1946 and done the same sort of studies they had and found that he wants to have a computer in the mathematical laboratory that could run any arbitrary scientific program to solve any arbitrary problem. and found that all the things in the USA were not either suitable or usable for that purpose. And he met a guy called John von Neumann. He missed John von Neumann's actually seminal presentation about the principle of the von Neumann machine, which is that you should need memory for the program and you need memory for the data, as well as other sort of faxes. But he met John von Neumann himself, and they sat down and discussed this concept. Von Neumann had probably picked up his ideas from Alan Turing in 1936, because essentially his ideas were about a programmable computer with a memory. But he never acknowledged that. But he told Morris Wilks about his ideas, and Morris said, "Oh, well, I know how I could use memory for a computer because I'm an engineer in radar. And in radar, we have got some devices that are memory devices called mercury delay lines, which are used to actually record the previous sweep of the radar. And I could use that to build a von Neumann machine in the Cambridge Computer Lab. And between the two of them, they sort of roughed out the design in the USA. Wilks got back on his ship, went back to the UK in 1947, started to design the EDSAC. They were short of funds. A group of people from Lyons had also been out there and been told about this development. So they put £3,000 into it, in modern day money about £100,000 into the development, for which they got the rights to the design, because they thought we can turn this into a commercial proposition for running business at Lyons. So they had the rights. 1947, the development of the EDSAC had started to happen in Cambridge. It ran through from 47 to 49. But an advert was put into, I forget what the journal was, probably Nature or somewhere like that, for an engineer to head this up, Dr. John Pinkerton, who was a graduate of Cambridge as well, and who'd worked with Morris Wilks, applied for the job because he had the skills that the advert said he should have. And he was recruited in January 1949 to head up the Lyons development. They were waiting for the EDSAC to finish and then they would take over the design. So Pinkerton joined in 1947. And John Pinkerton still worked for Lyons and English Electric Lyons until 1980s, I think, where I met him and did some work with him. They also recruited a project management team, T.R. Thompson, to head up the project, another Cambridge graduate, and David Kaminer, who was he'd lost one of his legs in the First World War, and he was recruited as an operational development manager. And he also was with ITL for many years, and I met him on several occasions. They explained to their people about a stored program computer and how it could be used for business. John Simmons was convinced that they could build a computer to help their business. There's a very basic layout of how they told computers worked. Binary data comes in, input, output, store, program processes it. The Leo original machine went at 500 kilohertz, but pretty slow. But they also recognized, because the EDSAC had been developed for scientific work, that actually for commercial work, there are a lot of different properties required. Whereas in scientific work, you needed numbers that were very large, very small, with variable precision. In commercial work, you needed not very large, very small, but specific precision. Scientific things needed sort of calculations of costs in, etc. But in commercial work, it's just plus, minus, percentage, etc. Everything in scientific stuff was numbers, but in commercial work, you needed actual text and stuff like that. So all of these different properties here were managed by Pinkerton to build into the machine that he developed. And you needed for commercial work a lot of input and output. They chose paper tape and punch cards. They got the punch cards off British Tab Company and the paper tape machines from Elliott Automation, who were using that for scientific work, and output from a teletypewriter, so they could print outward results. So paper tape in, buffering, punch card. One of the things they built into the machine was these buffers. Scientific work, you read a small amount of data and produce a small amount of data, but commercial work, you read a large amount of data and the amount of processing is to do with very little. So you have to overlap them. So they put buffers into the input and the output chain, which is work Pinkerton did. The machine had 6,000 valves in it, lots of resistors and capacitors, 220 assembly and 21 racks. And one of the things they did that was different to the EDSAC was to actually build modular components, so that things like a half adder, which does part of the add or subtract function in the computer, is a removable rack. And if it doesn't work, you can take it out and put one in that does work, and you can use the one that doesn't work offline and fix it. So they did a lot of work to make it more maintainable and more reliable. Because if you're going to do commercial work, it has to be reliable. You can't start the job and then fail. The memory that they used was the mercury delay lines, like in the EDSAC. They were 5'4" long, great big tubes of mercury, capacity of 8,000 digits or letters, not very big by modern standards, or in fact minuscule by modern standards. And no storage, no backing store on Leo 1, on the first Leo. If you wanted to store anything, you had to punch it out on paper tapes or cards and then feed it back in. They tried to get SCC to build magnetic tapes for them, but they didn't work. But during the construction of the Leo 1, it's important to consider what sort of people they needed. It wasn't just sort of logic designers or electronic designers. They needed electricians, mechanics, plumbers. There was a lot of plumbing going on in there, carpenters for building work stuff, draftsmen for the drawings, and work study men to actually work out how the business was working. And they employed subcontractors, Wayne Co Electronic Measuring Instruments Company, and Cameron Nicholson, I think, who made boats, which is a strange combination. So here's a picture of Leo 1 in Cadby Hall in 1951. The difference between it and the EDSAC was that it was all in cabinets, not naked sort of wiring. The cabinets had racks in them. It occupied 500 square meters, i.e. 2 tennis courts, and consumed 30 kilowatts of electricity and weighed about 2 tons. Amazing size of machine. And in November 1951, it ran its first application. It was the bakery valuations on the 5th of September 1951. Lyons' original target actually was the payroll. They employed over 30,000 people, and the payroll, while not to do with business effectiveness, is very much to do with business efficiency, because it was very costly to run, a lot of clerical effort. So one of their main targets was the payroll, but you don't want to choose payroll and then fail. So they then chose the bakery valuations as the first application they would program for the computer. And during 1951, they spent time developing that and ran the first, it says here September 1951, they ran the first trial run of it, but the first successful run in November 1951. So next year, November 1951, is Leo's 75th anniversary, and we're going to have a big lot of events to celebrate that and tell people about it. One of the very early visitors, which was great publicity, to view Leo 1 was Princess Elizabeth, who visited on the 15th of February 1951. And she spotted an error, but then the computer told her that, you see, I can do it. He fixed the error. Princess Elizabeth visited, and when she was written to before she died, not that long ago, she remembers her visit fondly. So having installed this thing at Cadby Hall, they found there's quite a lot of demand for bureau services for other people who want to use it. And not all of them commercial, some scientific, some commercial. So the Black Knight rockets calculations were done on Leo. The Ordnance Board's ballistic calculations were done on Leo. The Blue Streak missile was guided system calculations were done on Leo at Cadby Hall. And they then did various enhancements of improving the paper tape and punch card sensing. Originally, they were all mechanical or electromechanical, but they converted them all to electrical and photocell. So they did various things. And the second application they ran was in 1954, in January 1954, which was payroll for about 1,670 bakery staff. The total employees they had were 30,000, and eventually the payroll for all of them were done. But at this point, they just did 1,670. Main benefit was just straight cost saving of clerical staff, because clerical staff at that time after World War II had become very expensive and hard to get. To do a payroll calculation at that time took about 8 minutes for a manual person, and Leo did it in 1.5 seconds. And it also calculated all the notes and coins needed to actually fill the pay packets. And it also rounded up everybody's pay packet to the closest above convenient point. So everybody got what they were owed or more, but without too many coins and notes being required. So people either got their pay or a bit more, but not too many coins. They also established an applications development sort of regime and system analysis regime, library common programming functions, things like pound shillings and pence to pounds pence, organization and methods, looking actually at the approach of the organization and the way they were doing things, looking at the clear business needs and benefits, understanding the efficient manual process, and then design and validation. So basically, they were at the forefront of systems analysis and design at that time. Scientific computing didn't need these disciplines. You had an algorithm or something you needed to compute the results of, so you needed to program it, so you just programmed it. You didn't need to do a lot of analysis. In business, you needed to analyze the business system, analyze the requirements, devise and propose an efficient way to achieve the end objectives, and then do that. So that was the Lyons approach, systems engineering approach, and summarized here and from a sales brochure how they actually approach application development. Bureau activity, go back to that. They did budget day in 1954 to compute the new PAYE rates and everything for the inland revenue. They did a weather forecasting, a 1 day ahead weather forecasting in 1954 for the Met Office, who then eventually bought their own computer, but the first computerized weather forecast was done on a Leo bureau. But they came to the conclusion fairly shortly they needed a second computer for backup, as if the first computer wasn't working, they couldn't do anything. And there was a conflict between production, development, and engineering and maintenance. So expanding in-house work, expanding bureau work, and companies wanted to buy a Leo. And a requirement to improve the design. So they incorporated a separate company. The original company was just part of Lyons, 4th of November 1954, to develop computers. And they developed the Leo 2. Leo 2 is basically Leo 1 on steroids. It went from valves, resistors, etc., to valves, resistors on Bakelite boards. The memory was enhanced. It was made faster by interleaving and making more memory. A magnetic drum was incorporated. Line printer incorporated. Decca magnetic tape. The Leo one had SCC tapes, which never worked, and new registers and things like that. So lots of developments. And to actually then build this machine, they built a new building at Leo Computers on Minerva Road in Acton. First Leo 2 computer came out in 1957 in Elms House, Cadby Hall, May 1957. Leo 2 Bureau was operating in Hartree House, which was in Whiteley's department store in Bayswater from 1959. Now, I have a little story about this because in 1967, when I left Cambridge University, I was signed up to apply for jobs because the University Appointments Board thought I was probably a suitable candidate to go into the computer industry because I had a very poor degree in theoretical physics, which didn't fit me to do any job on the planet. They said, well, you might be good in the computer industry. So they signed me up to go to IBM, ICT, and English Electric. Won't go into the IBM story, but IBM didn't offer me a job. I'll tell you on another occasion. English Electric took me in for an interview. They told me to go to Hartree House to go for the interview and an aptitude test. Well, in those days, I knew Lily always was running late for everything. And they either didn't tell me or didn't notice that this place was actually in the middle of a department store. So when I get to Bayswater and I'm going down Queensway looking for Hartree House, I come to this department store and walk past it and there's nothing there. So I didn't know where it was. So by the time I got to English to Lyons in there for my aptitude test, I was already late. So I think I passed the aptitude test, but I failed the intelligence test because I couldn't find the office. So they didn't offer me a job. ICT did. So first sale of Leo 2 was September 1958. WD and H.O. Wells, £160,000, 4 million in modern money. The Duke of Edinburgh visited in 1960, and they played the sailor's hornpipe to him on the loudspeaker, which impressed him. Lots of other sales of Leo 2, Wells already, standard cars in Coventry, Ilford, Stewart and Lloyd's, Ford. Ford bought a Leo 2 in Britain before their parent company in the United States bought a computer there. Ministry of Pensions and National Insurance. So doing very well, thank you. Bakery valuations. The bakery payroll was developed further. Shop distributions, bakery wholesale sales, invoicing, tea shop payroll, the big payroll, tea blending, inventory management, all applications developed in Lyons. Tea shop distributions, where they used to actually try to forecast demand and just ask the tea shop managers to phone in their changes, making an efficient supply chain. And here was Simmons' master plan to automate everything in the business, tea shops, soup to nuts, with substantial savings for clerical staff that they thought they would achieve. Integrate greater production control and management information systems. That was their goal. Then they brought the Leo 3 in 1961, which was a more volume sale machine. We're going from valves to transistors, from mercury tubes to ferrite core. I'll go down some of these things here in one at a time. Magnetic drum, magnetic disc, magnetic drum to discs, faster register operations, laser page printer, and also it's not on this slide, I think here, but they went for more novel, very important input mechanisms. Here's the first Leo 3 at Elms House in 1962. And here are some of the sales of Leo 3 from 1960 to 1969. 58 Leos going to Dunlop, BOC, Cerebos, RBS. And one down there, I will highlight the GPO, General Post Office. Actually, this is the Post Office telephone billing. 14 Leos. In those days, Post Office telephone billing was a big application because they itemized billings, including local calls. So 1962 to 1969, quite a lot of success for Leo. Then they started to sell them overseas. South Africa ran gold mines, Consolidated Glass, Australia, Shell Group, Tube Makers, Colonial Mutual, Czechoslovakia, State Railways, Clement Steel Works, Social Security Office. But there were problems. They weren't making any money out of the computer sales. Their approach was a very Hindley systems analytic approach where they analyzed the business requirements and then made proposals. A very high cost of sale. And their cost of production was high. And they couldn't make any money. So they were sold in 1964 for 2 million quid to English Electric. Then the oil shock came, making business very difficult. And if you look at in the 1960s at competitor UK manufacturers, it was a very, very competitive environment. We had ICT, ex-British Tabulating Machine Company, Elliott Automation, ex-military, Leo, STC, ex-Telephones and Cables, English Electric, Ferranti Computer Systems, Marconi, EMI. In 1960, there were 220 computers sold in Britain and 90% were British made. But by 1970, 6,500 computers were sold, only 50% British made, because there was American competition as well. IBM launched the 360 range in 1964. And then Harold Wilson, in the white heat of technology, announced the speech he did on science and technology in 1963, where he's looking to consolidate the British computer industry. So 1963, Leo merged with English Electric. 1964, English Electric, Leo Marconi's. 1967, English Electric Computers with ICL. And 1968, the government-sponsored company with ICL, ICT ICL. By the early 80s, the GPO were still running their post office telephone billing on Leos, which were the magnetic tape units in particular were failing, pleaded for ICL to make 5 more Leo 3s. They actually developed a 2960 emulator to emulate Leo 3 and to supply that requirement so the GPO could keep on running their work, which is another story, which I can do on another day. By 1981, we had a partnership with Fujitsu in ICL. By 2002, Fujitsu ownership becomes total. They wrote to all the customers and said, do you see any value in the ICL name? And they all said no, because they felt ICL had let them down. In 2008, Fujitsu bought out Siemens to become Fujitsu Technology Solutions. And then we remain with the retirement of the Leo 3s. So that brings me to the end of my formal presentation. We have a Guinness Book of World Records of the first ever business computer, Lyons Leo 1, began operation. And I will stop my presentation and ask people for an unshare, if I can, my screen, and see if anybody has any questions or comments.
Well, thank you, Vince. That was, a fascinating talk. There's a lot of parallels with modern technology, with AI, thinking that's going to change computing. When you've described the changes from 1950 to business computing today. So fascinating insight into the history of development of business computers.
There are
Has
parallels,
any,
I think you're right.
yeah,
Have I unshared my
anyone got,
screen yet?
right?
Have I unshared my screen or not?
Yes,
Okay, good.
yeah, yeah. We just got the delegates. Is
Yeah,
there any
good.
questions that anyone would like to ask Vince?
Deathly silence.
I mean, the one question that I've got in my mind, in your view, and you've got a unique view of it, is there anything that British industry could have done to maintain the lead in computing?
Well, I think the British government should have done more than they did. They should have done what the US government did, and that's directly fund developments. All they did was to offer advantageous pricing, providing that you supplied what the government wanted,
Mm,
and what the government wanted wasn't what anybody else wanted, so it was
wanted.
hardly advantageous. Whereas IBM got billions of dollars for the development, which eventually went into the 360 series from the US government with no payback required. Um, but also, I think British inventiveness actually also funded the US computer industry. A lot of IBM's research was done in the UK.
Mm,
A lot of the 360 architecture was done in the UK. So I'm very proud of what Britain did in terms of computing development. But I think the key thing was in 1945, post-Second World War, we lost our main market, which was the Empire.
mm,
And we opened up competition to US competition, which we helped to fund. Uh, and so the end, we still have successful companies like ARM and others, and we're still exceptional in the software development.
mm.
But we, the government, maybe not, but we should have gone after mass markets, global markets, rather than just funding stuff for HMG, which is a small market globally.
Yeah. Mm.
Uh,
Because, I mean, also, do you think the rationalization that the government forced on the computer development industry had some negative effect on
yeah, I think it had a
reducing? Mm,
huge negative effect. They stripped out the mini computer and processor computer stuff where all the innovation took place, right,
all
and left
right.
the mainframes where there's no innovation. It's just satisfying people's previous needs.
Mm.
It's an
I
important
didn't
market,
realize
but
that. Mm,
yeah, I mean, Marconi left all their mini computers behind. Elliott Automation left all theirs. They all left everything behind.
mm.
The part of the industry that was innovative. ICL managed to restore part of that by buying Singer Business Machines,
Right.
which was a retail point of sale company. I went to the United States in 1980, and we were hugely successful in the retail market in the USA, and hugely successful in the UK. We had Waitrose, Sainsbury's, Tesco's, John Lewis, all the major retailers on point of sale systems. And it was a huge and very successful business and a successful potential on a worldwide scale, including the USA. But no, all the development was swung towards meeting Her Majesty's government requirements for the Inland Revenue.
All right.
What sort of market is that?
Mm. A very limited one.
That's
Yeah.
my view. Yeah.
Yeah. Right. Well, thank you. Very nice. Yeah, that was a really fascinating talk and insight. And I think it's one story that I certainly didn't know about it until I heard the talk about a year ago. And, after all my time in computing, I'd never heard about the development of the Leo computing, even working with Fujitsu and people like that.
Yeah.
Yeah.
No, Leo is really fascinating, and the guys that work for Leo are amazing. I mean, they single-handedly invented systems analysis and design, and people went on. Just trying to remember his name now. The guy that went into British Airways that developed Bodicea. He's dead now, but British Airways made huge amounts of money out of their real-time system for booking airline operations and that sort of stuff, and sold it to every airline around the world.
Mm.
And he learned his skills in Leo.
All right, good.
Chris Date, who's one of the pairs that invented relational database, he was in Leo in the early days.
All right. Mm.
Cod and Date.
Mm.
If you like a
So,
nice chat, we have got recorded talk by Chris Date about his time in relational database and his time working with IBM on DB2. IBM is a corporation he hates with a passion, having worked for them.
right. Well, we take that and we'll discuss it with the committee.
Mm.
So, any last questions? Have I sparked any other questions?
Yes, can I just ask, have you thought about publishing that? Because that's not well known, that your story. And I think, the new generation of computer science could do with learning all about that. Have you thought about
Yeah.
publishing it? Or even just a YouTube video somewhere would
Well,
be
we will be doing something next year. Next
Yeah.
year is Leo 175th birthday.
Yeah.
And so about leading up to November, we have some huge plans to do a lot of publishing of all sorts of stuff, in particular targeted at the younger generation. And bringing in people that will appeal to people from the younger generations, because the actual people that are currently interested are all dying, because they all started work in 1951 and they're now, if not dead, almost dead. So we believe it's really important that we actually get this message out to the younger kids and generate an interest to bring it in. So we are planning to do that, and in a major way. And by the way, we're looking for funding to help us do it. But we're certainly planning. We're doing it with Cambridge Computer History Museum, TNMOC, Science Museum, and with yourselves possibly. BCS.
Lovely, thank you.
Mm-hmm.
Yeah, thanks very much.
I have a really quick question. So, what is the most significant organizational or management challenge they faced during adopting this, revolutionary technology?
Not sure if I got the question. Can you say it again?
Yeah, sure. Yeah. So, what was the most significant organizational challenge or the management challenge they faced during adopting this technology during the time?
Okay. Well, Lyons themselves were pretty committed to using new methods to manage their business better, and they were investing in it. And they then decided to invest in developing a computer, which is a bit sort of an unusual thing to do. But the nature of the company was such that they were used to innovating. So it wasn't really a challenge for them to innovate. The challenge was that having innovated, they didn't realize that although this would bring them benefit for their business, they couldn't successfully compete in the UK market or the world market, which got really, really crowded. And their cost of sale was too high, and they had to get out. Lyons themselves eventually bought an IBM mainframe to run their business, because IBM made the lowest cost stuff, and the guy I'm trying to remember the name of bought IBM mainframes to run British Airways. British Airways made £40 million out of selling their services to other airlines, which more than paid for their own investment. So the challenge came from competition, I think. 6 or 7 British companies in the 1960s, 6 or 7 more American companies in the 1960s, all competing for the same business, is a very challenging market. And unless you can shoot for a world market, you will not succeed, I think. And IBM did shoot for a world market. Before World War II, IBM and British Tab had a cartel. IBM sold their tabulators well, British Tab sold IBM tabulators, I have to say, although under license, in the Empire. IBM sold their tabulators in the Americas, but also in Canada, which was part of the Empire, but part of the North American mainland. And they competed in Europe and Asia, that was not part of the colonies. After World War II, that was broken, that agreement. So ICL and the British computer companies became subject to American competition, which was too tough. And which we also helped to create through places like Hersley, which did the development of a major part of IBM's 360 series. Based on developments, by the way, of EDSAC and Leo with microcode. So we developed things to destroy our own market. But
we've got a
that's
question.
history.
Yeah, we've got a question come up. You mentioned early computers supporting radar. Do you know if there were any links between the various Leo computers and the likes of TRIAC and RREAC from the radar world?
I only know of people that came out of the radar world, like Pinkerton, who did the development of the Leo, who had knowledge of radar memory technology that they were able to use for computers. Other than that, I don't know of any links at all. No, I'll think about it, but I don't know of any offhand. Basically,
thank you, David, for your question.
People came out of Bletchley Park with knowledge about how to develop a computer because of code breaking. They came out of the USA because of knowledge of how to build atom bombs and compute it. They came out of Alan Turing by his concepts of a programmable computer. And that confluence all came together in the 1940s to develop modern digital computers. And it was all in people's brains. People say, well, was Churchill foolish to keep it all out of the public domain? The broad answer is no, because people knew about it. They knew what they'd done, and they knew what they could do. And they then developed computers from that knowledge. And many of them got no real recognition. Tommy Flowers hardly got any recognition. Bill Tuck got hardly any recognition. Not for many years because of the secrecy. Was the secrecy necessary? Probably. Churchill didn't trust Joe Stalin, nor did Roosevelt, and they were right. So they wanted to keep Bletchley Park and all that stuff completely secret. But did keeping it secret stop the development? I don't think so, not by and large. But it's a very interesting time. I was born in January 1945 of a mother who worked listening to Morse code for Bletchley Park in Scarborough. And she didn't tell me about that until the 1980s because they were all sworn to secrecy. But I joined the computer industry in 1967 and I got completely fascinated by early development of computers. It's been my sort of hobby and pursuit ever since. And I really like learning about it.
Yeah. One of the other questions we've got from Ben was, were the Leo 2 and Leo 3 computers developed with the help of Cambridge, as was the Leo 1, or was it independently?
I think almost certainly, only I have no documentary or other evidence, but EDSAC Mark II in Cambridge used microcode. Leo 2 used microcode. they are synchronous in time. It's too much to be just a coincidence. So I think they continued, but not in public, to actually liaise and to develop jointly. But there's no record of it.
No record, yeah. Well, thank you. And also, David had the second part of his question. Were there links between Bletchley, GPO, and the radar research work?
Radar came in because RRE helped develop the machine at Bletchley, which eventually became the Colossus. I mean, the personnel involved, they're all common. You find the same names circulating around at that time. What was the second part of the question?
Were the links between the GPO and the radar research work? Bletchley,
Yeah,
GPO, and the radar research.
The GPO did work with the radar research because the first development the prototype for Colossus was developed by RRE, but they used telecoms engineers, namely the same guy that developed Colossus, to do the work on the counting system. So they all worked together.
Yeah, and shared the knowledge. Yeah,
shared the knowledge. I have no documentary evidence of it, but I'm sure it happened.